Today I want to cover a couple of the problems that were giving some students difficulties. We are not going to go over problem one. For this, we are just going to go over some questions from problem two and problem three. As usual, you can find the code at the following link here on my GitHub. And we will just start off as usual by loading up dplyr, which I've already installed. So all I have to do is run the library for dplyr. And then we are going to use this quartet dataset. This is the actual dataset we are going to use in the homework assignment. So go ahead and upload that by using the read.csv function. And you'll notice that we have uploaded it. And we can just take a quick look at that with the head function. And we notice that we have a couple of observations for each of these columns. And so for 2b, we wanted to show a 2x2 plot. And so what you need to do is just use the par function, which gives you a 2x2 plot specified here. So you can run that. And then we will just be showing the plots of y1 and x1, which are actually the same data that we used for the regression in problem 2a. And we just want to plot y2 and x2 and so on and so forth. You'll have to add that data for plots 3 and 4 here. And then we're just using, to be clear, for each of these plots, we're just using the plot function as usual, and then this AB line function, and we're going to actually be using the regression of y1 and x1 as we want to show that line, that red regression line that I think I introduced in the last video. So if we run these two lines of code, you'll notice that you get the top two graphs, and you'll notice that we have that red line, which again was from the AB line function, and then we'll have the dots, so the scatter plot from this plot function. So that was pretty straightforward, but I just wanted to clarify what data set you should use and how you should set it up. And so now let's move on to problem P2C or 2C. And so what we want to do for this is just get the R squared from each regression. And the easiest way to do that is to use this R squared tag after we run the regression. So this is kind of a lot of code. I just put it all together. The first one is the usual regression that we run, and that just gives us the basic information. Unfortunately, it doesn't give us the R squared, as you'll notice. So we need to put that in the summary function. Previously, I was actually just saving it as reg output as the first step, and then the second step, putting that reg output in the summary. But you can just do this like this. You'll see. This is what I was doing before. But if you want, you can just put it all in one, which is what I'm going to do, just to save some space. And then I think you might have remembered that when you're using the summary statistic, it gives you all this information, which is a lot. It does show us the R squared, so if you want to just run it one by one, you can find the R squared. But if you just wanted to see the R squared data for everyone, you can just add that $sign and this R dot squared. And so let's run all the regressions and just grab the R squared from each regression. And what you'll notice is that we get the same R squared for each regression. And you might notice when you run the other plots and you see all four plots that the data actually looks quite differently, but all of the R squareds are the same. So just try to think about what that means for our interpretation of R squared, and I think you'll be able to hopefully answer that problem. So now for the next part, we are going to be doing problem 3. And this is actually, I think, a little bit more addressing what I think more people have been having trouble with, which is interpreting regressions, which can be quite a tricky thing. You shouldn't feel too frustrated, or don't don't get too down on yourself if you're not understanding it, because it's quite difficult to interpret regressions at first. And so we'll just try to walk through it together. We're going to be using the S Africa data set. This is wage data from South Africa. So let's just install it with the read CSV function and then look at it with the head function. And what you'll notice is that we have wage, age, education, experience, all this information on each individual. So just also remember that each row represents an individual, and that individual's wage and their other characteristics, as you can see here. We are now going to do problem 3A, and I will now have the notes here on the left side. And 3A is actually very straightforward. We just want to try to predict wage based on whether the person is female or not. And so that's actually relatively straightforward. It's kind of not straightforward in some ways, which I will explain in 1 second, but this is just the answer to 2A, so please take note. You're just going to use the LM function, and then wage, which is what we're trying to predict, is the Y, and then the X variable will be female. Please remember that this is this squiggly, okay, here, not the bar, okay? And so when we run that, you get this information, you just get the coefficients, but the question asks for a little bit more than that. I think it asks for the R squared and some other details. So you're going to want to run the summary function around that output that we just saved. Again, if you want to put this inside, the LM function inside of the summary, you can also do that, so feel free. But I'm not going to do that. I'm going to do it in steps, and then I'm going to run the summary function around the regression output, and then you will see that this is the information that you need. Now let's move on to 2B, and I will explain why we chose wage to be on the left side rather than the right side. So think about when you're doing a regression, the first thing you want to think about is what do we want to predict or explain? And usually in econometrics, it's actually more on the explain side. If you're doing stuff like machine learning, you're going to be wanting to make predictions. But the left-hand side is always what we are going to be predicting or explaining. So in this questions case, we actually want to be, we want to try to explain a person's wage given some other information. And in 3A, that information is whether they are a male or a female. So it's demographics. And so for that reason, the wage, or what we're trying to explain, is going to be the first piece of data that you put in, and then how you try to explain it will go after that little squiggly line. And for question 3B, sorry, this should be 3B. 3B, you're going to want to just put female, okay? Later we'll add some other explanatory variables as well. So when we run that, you'll get exactly the answer that we got up here. And just to be clear, the inverse, and I think some of you probably have run the inverse, which is female on the left side and wage. This is actually a different type of regression that we won't be covering in class. It's a regression known as logistic regression, and it's when the Y variable is a 1 or a 0. So it's a bit harder to interpret this wage variable if it's a logistic regression. And I'm not going to get into that because we're just kind of limited for time here, but if you want to know more, click on this link and feel free. So that's the first step, is just trying to figure out what we're trying to explain. And now we want to try to figure out how to interpret this regression. Okay, what does this negative 0.41 mean? What does this 6.8 mean? Well, I like to actually always look at the data, okay? We want to look at what it is we're actually putting into the regression. So let's look at the first, this is looking at the first 5 observation from our data set. I mean, if you want, you can just click on this too and look at it yourself. Sorry, I'm clicking on the wrong place. And so what we notice is that wages take the following values, 13.6, and the problem set explains that this is the hourly wage of people, right? So 16 bucks, 10 bucks. I think this is South African rand, so it's a different currency, but if you want, for simplicity, just think about it as dollars. So we just have a bunch of observations for that. And then for female, this is just a categorical or dummy variable. So it's just ones or zeros. Okay, so then now let's think about it. Let's think about how to read the coefficient now that we kind of refreshed what that data actually is. So if you look at here on the left-hand side, I created this. Hopefully that helps you interpret the regression. So y equals beta, beta 0 is the intercept, and then beta 1 is the female. So it's a 1 or, excuse me, beta 1 is the coefficient. And then x1 is either the 1 or the 0. So in our case, what we see in our regression, if you want to just run this reg 3a again, you'll see that the intercept is 6.85 and the female coefficient is negative 0.41. And I just wrote that up here just for simplicity. And so what that actually means is that the average person makes $6.85, okay, if they are a male. But if the person is female, what you're going to want to do is, in the case that they're a male, excuse me, this x1 will be 0 because the dummy is 0 for males. And if the person is a female, this x1 will take a value of 1, okay? And so when you try to predict what the average female wage would be, you take the average person here, so 6.85, plus negative 4.12 times 1, which is obviously just negative 0.412, and obviously it's just minus 0.412. So in the end, what I'm going to do here is I'm going to just go through these line here on 98 and 100, and I'm actually just going to try to save these coefficients. This is just the data to save the female coefficient, and this is just the code to save the intercept. So I'm just gonna save that. Actually, I need to run that regression first. So we'll go back up to step 1, and then we're going to try to save the female and intercept dummies that we have here. And it looks like these have been saved. And now we are going to get to the final step, which is I like to call it the sanity check, or just the chance to think about what the regression means by using it as an example. I briefly just introduced it, but let's just go through it step by step. So for the woman's wage, as I said, it's going to be the reg 3a intercept, so that 6.8 value, plus, so we're on line 110 here. Let's scroll down a little bit. So it's going to be the intercept, as I have it here, plus the female coefficient times 1, because 1 indicates that the observation is a female. So it's just simple math, and you're just putting to work the data that I have here. This formula, more or less. It just becomes a formula. And that's why I wanted to write it out like this. So sorry if that was more confusing than it probably should have been, but I like to try to explain it by just running the formula myself. And I have this woman wage variable that's now been saved, and what you will notice is that the average woman wage is $6.44. And if we wanted to do that with men, we would do the same intercept, of course, because the intercept always remains the same, and then plus that regression coefficient. But in the case that it's a male, this x1 value here will be 0, okay, because it's not female. And so obviously this coefficient will then turn to 0. And what you will notice when you run this is that the average wage for a man is just 6.85. It's just what we have here in the intercept. All right, so that is how to interpret the regression. Again, if that was a bit confusing, try to maybe rewind and watch that section again, but I'm going to try to explain the coefficient in question 3C. So let's just do it one more time and see if we can build on what we just did. So again, we are going to just save the regression in 3C as this. It's going to be using the LM function, of course, and it will look exactly like the regression we just did previously, but you're going to add another explanatory variable for education. And so you do that just adding a plus sign and then the name of the variable or the name of the column, right? It's just a column here, education. And then you're going to save that. And then we're going to take a summary of that. So that's what I'm just doing here. And now we're going to try to interpret again. So let's think of it as an example, right? Let's just run 3C just to get an idea of what all the coefficients are first. So our intercept is 2, so it dropped dramatically. But female is still negative, okay? And it's actually, I think, more negative, right, than we had last time. And education is a positive value. So again, we are trying to explain wage, that y variable here. We have that intercept, and we have the female variable multiplied by whether that person is a female or not, so that's a 0 or a 1, plus education, okay, and I put in the education coefficient here, times the person's education. Now, education is not, obviously, a categorical variable. It's not 0 or 1. If we look at our data, you'll see that some people have educations of 13, 10, 6, right? There's very different levels of education. So, again, this is just a formula. If you wanted to try to figure out what the average wage for, say, a female who has 10 years of education, you would take this intercept. Always the intercept is going to be there, and that won't change. And then you're going to add this female coefficient times 1 if it's a female. It would be multiplied by 0 if you're trying to explain or predict what the male wage would be. And then, again, if you wanted to see what the average female with 10 years of education would make, you would add this coefficient times whatever level of education that was. So again, 10 years, you could just multiply it by 10. This is very similar to the example that I gave from, I think, problem set 5 with the cigarettes. We were trying to predict the baby's weight. And we were trying to predict the baby's weight for a mother who had smoked 20 cigarettes, right? And it's just a similar concept. And I just created this regression function. It's probably a little bit confusing, but yeah, sorry, that's the door. Somebody will get that, don't worry. What we're going to do here is try to create a function where you can input some female dummy, so whether they're a female or not, and then you can input the years of education, and then it should be able to predict our wage. So I'm just running the regression here, saving that regression. I'm saving the coefficients from the female, from the intercept, and from education. This is all code that you saw previously. As numeric, just saves something as a number. And then what I'm actually doing is I'm predicting that wage exactly like I'm doing it here, right? So I'm doing this reg3a intercept, which is just the intercept, which is 2.14. And I'm adding this reg3 female, which is negative 1.42. And then I'm going to multiply that by either the 1 or the 0. That will be input here. And then I'm going to add the coefficient for education, which is this 0.8, and that's saved in this part here. And then I'm going to multiply it by this years of education, which is exactly that input here. Okay, so this female dummy will be multiplied by this here. This years of education will be multiplied by this here, and the intercept, of course, will always stay the same, so we don't input the intercept. So let's just save this regression function. You don't actually need to understand the whole details, but I really encourage you to play around with this a little bit. This regression function now I can use. It's been saved here, and I am, for this example, doing exactly the same thing we just did, is predicting a female's wage who has 10 years of education. So I'm running that, and the computer is thinking, and it tells me that that average wage would be $8.67. Let's see what a man would be with the same level of education. Well, the man has a significantly higher wage. You'll notice it's $10, right? You could do 5 years of education for a male, right? It's a lot less, obviously. It's 6, right? You could do 15 years of education or 14 years of education for a male. And obviously, the number is going to go up. The average predicted wage would be 13. Okay, so this was just an exercise to try to get you to think about how to predict that wage and how to interpret each of these coefficients, okay? And when you're interpreting the coefficients, you are holding all else constant. I think maybe the professor introduced you to that concept. So when you are reading the coefficient, interpreting it, you'll say that on average, females will have, they will make on average less, $1.4, excuse me, less on average, holding all else constant. Okay, you're not, when you interpret that female dummy, you're not thinking about education. You're not thinking about, you are thinking about the intercept insofar as you can calculate the average female's age, or excuse me, wage, by just subtracting that or adding it. Say if it was positive to that intercept, then you'll be able to find out that average. So again, I recommend that you play around with that a little bit and maybe even look at the code if you want to try to figure out what I did there. Now we will move on to just comparing the R squared from both models. And so I had just saved each of those regression outputs. The one from 3C, which is the one which has education, will be here. Let's just clear this up so you can see it very clearly. And that R squared is 0.13. And the R squared from the first model, where we only use female as an explanatory variable, is 0.000. So this is actually a very bad fit, and it shouldn't be surprising, right? Because we know that wages are determined by way more than only one explanatory variable, right? It is going to be explained by where you live, what university you went to, potentially the quality of university you went to. There's all these different factors that go into explaining wages. So it does make perfect sense that when you only have one explanatory variable, that the model is going to be really weak, right? But when we add education, you'll see that it actually increases significantly. So it's actually tends to be a pretty good determinant of how much a person makes. Now we are just going to do one final regression, and this is kind of the granddaddy of all of them in a lot of ways because we're just adding a lot more. So we're adding education, age, whether they're in a union, whether they're married, and whether they live in an urban area. So let's run that. And I highly recommend that you just, go through and think about what all these mean. And maybe even pause the video and think about it. But I will just quickly go over it now. The intercept is a bit wonky in this case because it's negative. don't worry about that too much. When you think of an example, you're always going to have a person who has a positive wage, obviously. And that's because things like education and age, they're variables that are numeric. And so no one has a zero education, or maybe some people do, but it's very rare. And no one has generally zero experience or zero age, right? Not in our data set, at least. So by the time you try to account for that, when that sanity check that I call it, or trying to explain it yourself, you're going to find that it's going to be positive. So let's just take an example, I guess. I mean, let's just do it really quickly here. You have the intercept. I'm just going to type it out just for ease. Let's say that that person is a female, so it's 1.29. This is just a rough estimate. I'm not going to type out the whole thing. Let's say that that person had an education of 10. So 10 times 0.71 plus an age of, let's say, a 20-year-old times 0.06 plus, they're not in a union, 0 times 0.716 plus, let's say they are married, 1 times 1.004, and then let's say that they live in an urban area, so 0 times 1.54. The reason I'm putting zeros on urban and married, well, married is a 1, but the reason I'm doing that is because these are just dummy variables. Same with union. Age is not, education is not, and female is not. So when this is just kind of a random person that I chose with all those random characteristics that I chose, and their average wage would be 9.4. So let's just also go over just one more time what everything means. According to this model, females would on average make $1.29 less than males, according to this model, holding all else equal, okay? Not thinking about education or age or anything. Education, you're going to get 71 cents on the dollar for each additional year of education, right? It's a little bit different of an interpretation, right? Let's just make that clear. I maybe didn't make that clear enough before. Then for age, it's as you get 1 year older, your wage goes up by 0.06 cents. It's quite small, but if you think about it, if you're an 80-year-old, that kind of adds up, right? It's 80 times that age on average, okay, holding all else constant. Unions, if you work in a union, you make about 71 cents more per dollar, which I guess makes sense as well. If you're married for whatever reason, that I don't really know, I'm not a sociologist, so I don't know why that would be, but you get on average one more dollar, or it's associated, excuse me, with one more dollar in earnings per hour. And then urban is on average, holding all else constant, not thinking about any of the other variables, you get about 1.54 more dollars for your wage, which makes sense. Some of these are intuitive, some are not, right? Married is harder to explain, and even female, right? And this, I guess, touches on the last question. This shows constantly that female wages are lower than men, and so there is very good evidence that there is some discrimination against women. But what regression can show you is that there is evidence, but it can't show you why, right? I mean, we don't know exactly the mechanisms of that by just running the regression. You would probably need a lot more advanced study, sociologically or even more data to show exactly why that might be. And of course, there's obviously many different theories and reasons, especially in the United States. So, but without getting that into too much detail, Let's think about, so I think 3E is, again, I think we covered that just now. And then the F stat is, we don't actually have to use this. We can just run a summary of our regression, and I can just show you very briefly. I think you might have covered it in class, but when you're looking at individual coefficients and then the t-values, you are only running a t-test or a statistical test on whether that coefficient, whether that explanatory variable is significant or not. If you wanted to run that same kind of test, you can run that same kind of test on your whole model as well, and that is called the F statistic. And so the F statistic in this case, the null hypothesis is that the model is not does not do a good job or is not statistically significant at explaining whatever it is that you're trying to explain, your Y, right? So in our case, it's wage. But if you get a very tiny p-value, which we have, we can reject the null. And the alternative is that the model is statistically significant. So that is how you interpret that F. And I think that pretty much wraps it up. So thank you for listening to the videos this semester. I hope they helped out. And unfortunately, didn't get to meet a lot of you, but if you want, please just send me an email and I'd be happy to give you more additional resources if you're interested to continue studying RStudio or Python or other statistical languages that I think are pretty important these days. So thank you for listening again, and have a good holidays.